When I first began recording wild soundscapes 45 years ago, I had no idea that ants, insect larvae, sea anemones, and viruses created a sound signature. But they do. And so does every wild habitat on the planet, like the Amazon rainforest you're hearing behind me. In fact, temperate and tropical rainforests each produce a vibrant animal orchestra, that instantaneous and organized expression of insects, reptiles, amphibians, birds, and mammals. And every soundscape that springs from a wild habitat generates its own unique signature, one that contains incredible amounts of information, and it's some of that information I want to share with you today. The soundscape is made up of three basic sources. The first is the geophony, or the non-biological sounds that occur in any given habitat, like wind in the trees, water in a stream, waves at the ocean shore, movement of the earth. The second of these is the biophony. And the biophony is all of the sound that's generated by organisms in a given habitat at one time and in one place. And the third is all of the sound that we humans generate that's called anthrophony. Some of it is controlled, like music or theater, but most of it is chaotic and incoherent, which some of us refer to as noise. There was a time when I considered wild soundscapes to be a worthless artifact. They were just there, but they had no significance. Well, I was wrong. What I learned from these encounters was that careful listening gives us incredibly valuable tools by which to evaluate the health of a habitat across the entire spectrum of life. When I began recording in the late 60s, the typical methods of recording were limited to the fragmented capture of individual species like birds, mostly in the beginning, but later animals like mammals and amphibians. To me, this was a little like trying to understand the magnificence of Beethoven's Fifth Symphony by abstracting the sound of a single violin player out of the context of the orchestra and hearing just that one part. Fortunately, more and more institutions are implementing the more holistic models that I and a few of my colleagues have introduced to the field of soundscape ecology. When I began recording over 4 decades ago, I could record for 10 hours and capture 1 hour of usable material, good enough for an album or a film soundtrack or a museum installation. Now, because of global warming, resource extraction, and human noise, among many other factors, it can take up to 1,000 hours or more to capture the same thing. Fully 50% of my archive comes from habitats so radically altered that they're either altogether silent or can no longer be heard in any of their original form. The usual methods of evaluating a habitat have been done by visually counting the numbers of species and the numbers of individuals within each species in a given area. However, by comparing data that ties together both density and diversity from what we hear, I'm able to arrive at much more precise fitness outcomes. And I want to show you some examples that typify the possibilities unlocked by diving into this universe. This is Lincoln Meadow. Lincoln Meadow is a 3.5-hour drive east of San Francisco in the Sierra Nevada mountains at about 2,000 meters altitude, and I've been recording there for many years. In 1988, a logging company convinced local residents that there'd be absolutely no environmental impact from a new method they were trying called selective logging, taking out a tree here and there rather than clear-cutting a whole area. With permission granted to record both before and after the operation, I set up my gear and captured a large number of dawn choruses to very strict protocol and calibrated recordings because I wanted a really good baseline. And this is an example of a spectrogram. A spectrogram is a graphic illustration of sound with time from left to right across the page, 15 seconds in this case is represented, and frequency from the bottom of the page to the top, lowest to highest. And you can see that the signature of a stream is represented here in the bottom third or half of the page, while birds that were once in that meadow are represented in the signature across the top. There are a lot of them. And here's Lincoln Meadow before selective logging. Well, a year later, I returned, and using the same protocols and recording under the same conditions, I recorded a number of examples in the same dawn choruses, and now this is what we've got. This is after selective logging. You can see that the stream is still represented in the bottom third of the page, but notice what's missing in the top two-thirds. And coming up is the sound of a woodpecker. Well, I've returned to Lincoln Meadow 15 times in the last 25 years, and I can tell you that the biophony, the density and diversity of that biophony has not yet returned to anything like it was before the operation. But here's a picture of Lincoln Meadow taken after, and you can see that from the perspective of the camera, or the human eye, hardly a stick or a tree appears to be out of place, which would confirm the logging company's contention that there's nothing of environmental impact. However, our ears tell us a very different story. Young students are always asking me what these animals are saying, and really, I've got no idea. But I can tell you that they do express themselves. Whether or not we understand it is a different story. I was walking along the shore in Alaska, and I came across this tide pool filled with a colony of sea anemones, these wonderful eating machines, relatives of coral and jellyfish. And curious to see if any of them made any noise, I dropped a hydrophone, an underwater microphone covered in rubber, down the mouth part, and immediately the critter began to absorb the microphone into its belly, and the tentacles were searching out the surface for something of nutritional value, the static-like sounds that are very low that you're going to hear right now. Yeah, but watch. When it didn't find anything to eat, I think that's an expression that can be understood in any language. At the end of its breeding cycle, the Great Basin spadefoot toad digs itself down about a meter under the hard-pan desert soil of the American West, where it can stay for many seasons until conditions are just right for it to emerge again. And when there's enough moisture in the soil in the spring, the frogs will dig themselves to the surface and gather around these large vernal pools in great numbers. And they vocalize in a chorus that's absolutely in sync with one another. And they do that for two reasons. The first is competitive, because they're looking for mates. And the second is cooperative, because if they're all vocalizing in sync together, it makes it really difficult for predators like coyotes, foxes, and owls to single out any individual for a meal. And this is a spectrogram of what the frog chorusing looks like when it's in a very healthy pattern. Mono Lake is just to the east of Yosemite National Park in California. And it's a favorite habitat of these toads, and it's also favored by US Navy jet pilots who train in their fighters, flying them at speeds exceeding 1,100 kilometers an hour and altitudes only a couple of hundred meters above ground level of the Mono Basin. Very fast, very low, and so loud that the anthrophony, the human noise, even though it's 6.5 kilometers from the frog pond you just heard a second ago, it masked the sound of the chorusing toads. And you can see in this spectrogram that all of the energy that was once in the first spectrogram is gone in the top end of the spectrogram, and that there's breaks in the chorusing at 2.5, 4.5, and 6.5 seconds. And then the sound of the jet, the signature, is in yellow at the very bottom of the page. Now, at the end of that flyby, it took the frogs fully 45 minutes to regain their chorusing synchronicity, during which time, and under a full moon, we watched as 2 coyotes and a great horned owl came in to pick off a few of their numbers. The good news is that with a little bit of habitat restoration and fewer flights, the frog populations, once diminishing during the 1980s and early 90s, have pretty much returned to normal. I want to end with a story told by a beaver. It's a very sad story, but it really illustrates how animals can sometimes show emotion, a very controversial subject among some older biologists. A colleague of mine was recording in the American Midwest around this pond that had been formed maybe 16,000 years ago at the end of the last ice age. It was also formed in part by a beaver dam at one end that held that whole ecosystem together in a very delicate balance. And one afternoon, while he was recording, there suddenly appeared from out of nowhere a couple of game wardens who, for no apparent reason, walked over to the beaver dam, dropped a stick of dynamite down it, blowing it up, killing the female and her young babies. Horrified, my colleague remained behind to gather his thoughts and to record whatever he could the rest of the afternoon. And that evening, he captured a remarkable event. The lone surviving male beaver swimming in slow circles, crying out inconsolably for its lost mate and offspring. This is probably the saddest sound I've ever heard coming from any organism, human or other. Yeah, well, there are many facets to soundscapes, among them the ways in which animals taught us to dance and sing, which I'll save for another time. But you have heard how biophonies help clarify our understanding of the natural world. You've heard the impact of resource extraction, human noise, and habitat destruction. And where environmental sciences have typically tried to understand the world from what we see, a much fuller understanding can be got from what we hear. Biophonies and geophonies are the signature voices of the natural world. And as we hear them, we're endowed with a sense of place, the true story of the world we live in. In a matter of seconds, a soundscape reveals much more information from many perspectives, from quantifiable data to cultural inspiration. Visual capture implicitly frames a limited frontal perspective of a given spatial context, while soundscapes widen that scope to a full 360 degrees, completely enveloping us. And while a picture may be worth 1,000 words, a soundscape is worth 1,000 pictures. And our ears tell us that the whisper of every leaf and creature speaks to the natural sources of our lives, which indeed may hold the secrets of love for all things, especially our own humanity. And the last word goes to a jaguar from the Amazon. Thank you for listening.